Sand and water, perhaps the two things that appear in every description of the central sands of Wisconsin. To the geologist, it is a region of deep sands left behind as the last glaciation retreated some 15,000 years ago. To the hydrologist, it is a region of productive aquifers in which the groundwater is but tens of feet below the surface. To the farmer, it is a region of sandy soils that require frequent irrigation, but which offer great advantages in the production of high-value vegetable crops. Politically, the region spans portions of Wood, Portage, Waushara, Adams, and Marquette counties. It has provided generations of families with outdoor recreation, and pine plantations have long supplied the paper industry. Here, groundwater is intimately connected to the surface water, supporting recreation and life. As goes the groundwater, so goes the surface water resource. Early attempts at agriculture in the region were frustrated by the low water holding capacity of the sandy soils. But with the 1950s came new technologies of aluminum fabrication and turbine water pumps, making possible the age of irrigated agriculture. Conversion of lands to irrigation proceeded rapidly, and further development continues apace. The region's crop production is a central piece of Wisconsin's $6 billion specialty crop industry. Potato and vegetable production generates some $700 million of economic activity annually, and these raw crops feed this $5 billion industry that processes and markets them. Tens of thousands of jobs are associated with the specialty crop industry statewide. As irrigated agriculture in the region proliferated, the University of Wisconsin and United States Geological Survey scientists began analyzing both how to foster growth of the industry and what the implications of this might be for the waters of the region. Analyses during the 1960s indicated that stream flows had already been impacted by irrigation and that continued expansion would cause significant harm. In the late 1990s, groundwater in the region fell to such low levels that streams and lakes went dry. Previous levels this low had been associated with historic droughts in the 50s and 60s, but no obvious cause for the new levels can be found in annual precipitation totals. Explanations center around three possibilities. One, that the cumulative impact of extensive irrigation had finally become obvious, as predicted decades ago. Or two, that features of the region's climate have changed fundamentally, disrupting the earlier water balance. Or three, present groundwater levels are the result of some subtle sequence of recent weather, and they will return in due time. Good scientific evidence exists only for the first of these, that the cumulative effect of the many wells in the region has lowered the groundwater. Research continues to sort through these possibilities. Meanwhile, conversion of lands from rain-fed perennial vegetation to irrigated crops continues. Regulatory oversight of groundwater wells considers the impacts of individual wells on nearby water uses, but lacks provisions that address cumulative impacts of many wells. The water situation in the Central Sands provides an extraordinary opportunity for extension to demonstrate its ability to meet the interests of multiple and diverse constituencies.